Good evening and a very warm welcome from a little bit cold Emmen. My name is Adrie Wisman and this evening I will lead you along a lot of interesting topics, interesting segments, and let me get my presentation like this and like that. A short introduction for those who haven't been here before. This is BlockchainLab Drenthe, and BlockchainLab Drenthe is a non-profit foundation that has the goal to spread knowledge, insights and experience along to students, schools, governmental bodies, entrepreneurs, private people who are interested in blockchain. Now, we do this with meetups like this, but we also lecture at schools, middle technical schools, but also University of Applied Sciences. We give guest lectures and all that kind of stuff. We also do blockchain projects, and you will see a few of them this evening also on the screen. We are heavily invested in Interreg Project Bling, and you saw Interreg Project Bling also here. Interreg Project Bling, which is a European project, and Bling stands for Blockchain in Government. So that's 6 North Sea region countries and 14 partners in there who are all into blockchain pilots for public services. And we do that specifically for the province of Drenthe, the municipality of Emmen, and the city of Groningen, for instance. But in Bling there are also other partners. You can think of University of Gothenburg, University of Edinburgh, University of Applied Sciences Ho West, City of Antwerp, Roeselaar, CGIB here in Holland, University of Oldenburg, to name a few. I've missed a number of them. I'm sorry, I don't know them all by head, but that's Interreg Project Bling. Let me go to the next slide. YouTube is kind of a one-way street. You can see me, but I cannot see you. But we still would like some interaction. So if you have any questions, please use the chat window, the YouTube chat window. Post remarks. Please let us know who you are and where you're from. I saw already some people also from Germany. So post your questions there and I will try if I can answer your questions if it's possible. Now, all our meetups have the same format. We have 3 segments. The first segment is what's going on in the blockchain space, with some news, some price action, but also a segment about scams. And this evening that segment is extra large because there is a lot of news about one particular big scammer I will tell you about in a moment. And then we have a segment by Jeroen Wester, and he is going to talk about artificial intelligence, trust and blockchain, what they have to do with each other and how they are intertwined and how blockchain can help artificial intelligence. Then there's a segment by me again, which is about Ethereum, about Ethereum 2.0 to be more specific, the merge and beyond. It sounds like a sci-fi series. To space and beyond. Here you can also see the date of our next meetup, which will be on December 22nd. Okay, now let's start with the first segment, right? Let's dive right in to the news segment. This is the market action of today, and we saw that today 80% of the coins are going up. That has been a little bit different in the last month. But today everybody was very positive. You see here, this is the screen where most of the people who start with a blockchain are interested in. And we see here 10 coins with the biggest market cap, but there are thousands of coins which are on exchanges which people can trade. Here you see a little bit more oversight. These are the figures of today. So there are nearly 22,000 different coins and coins pairs on exchanges which can be traded. And if we compare that with January the beginning of this year, it were only 17,000. And January a year ago, so 21, it was only 8,000. So everybody and their mother are designing their own coins and listing them on exchanges, even though the market has been going down. So let's hope those are utility coins. If we look at the market cap, yeah, that's been going down radically this year, right? If we look at January to November, we saw market cap going down from 1.9 billion to under a billion, 832 million, which is a lot of money still, but it went down nearly 60%. And market cap is the value of all these coins summed up and expressed in US dollars. If we look at the Bitcoin at the moment, it's at 16,572, and this year it's been going down over 60%. Ethereum also even a little bit more, 67% down. And I have some graphs of that. Here you see the Bitcoin versus US dollar since January 1st, 64.2% down. The word bloodbath comes to mind. And a lot of people stepped out of the crypto market, didn't like it anymore, invested elsewhere. Because you have to do something with your money, inflation is going up. Same for Ethereum, 67.5% down since January 1st, and has hardly seen this little green dot at the start of the year was the only time it was in a plus, and the rest of the year it's been going down. Now, granted, since around June, half June, it's been at this consolidation level, or even with the scam we're going to talk about, which happened in November. Bitcoin made a new low on that, a scam, as you can see. Ethereum did not. Last month, here you can see what happened on the 8th of November. It's hard to oversee. All coins went down because of this earthquake that happened because of only one man and his fund, FTX as an exchange. I'm going to talk about that extensively in a moment. Ethereum, exactly the same. It was up, but 8th of November, everything just exploded or imploded, went down on high volumes, as you can see. Everybody wanted to sell. Okay, now the rest of the news. And I'll start with BlockchainLab first. All right, we did a lot in the last months. Our last meetup was during summer because of I had COVID for more than a month, and it was pretty severe. So a number of meetups were impossible to transmit. But other things happened. For instance, in June, BlockchainLab Drenthe became a member of the Dutch Blockchain Coalition. We've been working towards that for a long time. June 28th in Utrecht, we signed the contract, so to speak, the covenant, with two other Dutch Blockchain Coalition hubs to be a representative of the Dutch Blockchain Coalition in the northeast of the Netherlands, helping entrepreneurs, helping startups who want to get involved in blockchain. This is something else. Here, my colleague Jeroen Wester went to Gran Canaria to speak at the Fiber Summit about, of course, our energy knip, which is one of the largest, if not the largest, blockchain project in the Netherlands. And everybody is curious about how we did that, how we scaled up our energy knip. And so it was the topic at the summit September 14th in Spain, or better on the island Gran Canaria. That's me in Berlin in October. That's when my COVID hit. And in October, I was speaking there at the IOTA Experience Weekend. As you might know, most of our blockchain applications are built on the IOTA protocol. And so we had a chance to show our energy knip, but also other applications at their Experience Weekend. And it was very nice to be there and talk with other IOTA-minded people. This was last week, where I had the chance to speak at the podium of the Smart City World Expo and Congress in Barcelona, also about our energy knip. And the Smart City World Expo is a very large expo where all kinds of smart city applications are showed to municipalities and cities all around the world. It was a 3-day event where, well, like I said, half the world would be coming to Barcelona about smart traffic lights and energy and mobility and etc. Not too many applications about smart money, right? But we didn't care. Maybe we are one of the only ones. I saw 2 other companies talk about smart money also. So that is energy knip going international, so to speak. International also next week, where I'll be speaking in Berlin at the Decentralized Sustainability event organized by the Dutch Blockchain Coalition, the Embassy of the Netherlands, BlockchainLab and Berlin Agentur. It's a 1-day event where all kinds of blockchain applications will be shown and be presented. And we are one of the first and largest blockchain applications in existence, where tens of thousands of people are working with our app. So lots of companies and lots of governmental departments are very curious to find out how it works and how the people are reacting to it. So in Berlin on the December the 1st. And the last conference that I'm going to this year will be here in the Netherlands again, in Heerlen. Maybe if you are in the vicinity, living in the south of the Netherlands, or even in Germany, this is in the vicinity of Aachen. So if you have the chance, this is a conference which will be in English. So the December the 15th, this is from Utrecht Blockstart, which is a project where most of the companies attending are small and middle enterprises. In Dutch we call it MKB. So they have different kinds of applications, but it's not the Shell and the Unilevers of this world. This is their end conference. The Blockstart project has been running for 4 years, and so they are presenting all their projects. And we will be there also. I will be speaking on public services and blockchain, and we will be showing our energy knip, our self-sovereign attendancy application. We'll be showing the vitality knip, and we'll be showing the Parkstad energy knip. I will put the link to that registration in the comment of the YouTube movie later on, so you can click it, so you don't have to write it down. Okay, this happened a few weeks ago. Maybe you know our Energy Knip application, where we have a QR code card which people use to register their wallet on their phone here in Emmen at first. The Energy Knip has been rolled out to the south of the Netherlands also, and it has been used by the region Parkstad, which is a region consisting of 7 municipalities who wanted to distribute 5 million euros to 20,000 families who are in financial trouble because of the increasing energy prices. Right, so what they did was they sent all these families who are at risk a letter with a QR code, and after registering, they didn't have to answer any questions like the Emmen Energy Knip, where we wanted to also to retrieve data about behavior, about if you have solar panels or heat pumps or whatever. No, these people were in it only for receiving the money. So after scanning their QR code, let's say 3 minutes later, they could go to hardware stores and buy goods with which they could lower their energy bill, because that is necessary. Winter is coming and they have trouble paying for their energy, and this could help. So this was the fastest way that these municipalities could get the money to these people with a simple letter. That's a website. You can go and look if you would like to. It's called parkstad.energieknip.nl. It's written like that, parkstad.energieknip.nl. Okay, now to the rest of the world, the news around us. This was all about us, but now it's about the rest. There's been going on a lot in the blockchain space. Everybody's been talking about CBDCs, central bank digital currencies. The digital euro is coming. Digital yuan is already there. Japan decided this week that they are going to experiment with their digital yen. And we also know that, for instance, in India, they are working on the digital rupee. So there are lots of regions and countries working on their own digital money, which is in Europe still pretty hard to do, right? Because all these banks have to decide on how to design it, and how shall I put this politely? It's more talk than build. I've been talking to the Dutch National Bank and even the Deutsche Bundesbank, and yeah, well, they are still having considerable second thoughts about blockchain. So they are designing it in their own way. I told them, you can look over our shoulders. We already have 10,000 people in Emmen working with it, 20,000 people in Parkstad, etc. So we have experience. Work with us. We'll see if they will do that. But Japan is going on that train also, and they want to start experimenting next year with that. Proof of work in this period of time where energy is very scarce and very expensive. There has been talk about this in Europe also. Governments want to prohibit miners using proof of work, like Bitcoin. So there are lots of miners who are trying to earn money, who are putting their miner farms in countries where electricity is cheap. Well, that's getting harder and harder, as you can imagine. But these governments say we want to rule that out totally. And this time it's the New York governor who signed a moratorium, a law which says miners cannot use proof of work anymore. And so we will probably see miners moving out of the state New York, maybe to Canada or whatever. because they are not allowed to use proof of work anymore. It's a trend that is going on for, let's say, a little bit more than a year. And it has been done here in Europe also, but it was rolled back. Yeah, well, in the face of all the scams that are happening and people getting caught, I can recall that the two people who had all the Bitfinex money, $4.6 billion, or it was 6 billion, if I am correct, then these people got caught. And so there are more and more companies specializing in finding the people who own certain coins. Right now, the scam that I'm going to talk about in a minute, also there is money lost, and there are companies like Chainalysis and other companies who are watching with binoculars what's been going on the blockchain to see if they can capture the crooks. Now, the crooks see that also, so they are switching from Bitcoin and especially Bitcoin to other coins which are a little bit harder to trace. There are coins that are untraceable, like Monero, like Dash, etc. But those are prohibited in Europe. You cannot own Monero, and no bank will do business with you if you have Monero in your wallet. So that's not done. But the most known coin, Bitcoin, yeah, well, it's being mapped, so nearly everyone can see who owns what. It's pseudonymous, of course, but there are laws that you have to register at an exchange, show your passport, so it can all be traced back to you. And crooks see that also and say, well, we're not going with Bitcoin anymore, we're going to use other things. In that same wake of that scam, where lots of coins were withdrawn from companies, for instance, yeah, people see that the old adagium, not your keys, not your coins, is true. That if you leave your coins on an exchange and that exchange is being hacked, then your coins are gone. So there are a few companies who are making a profit of these scams. And here you see one, Trezor, also Ledger, who sell these USB sticks that can hold your private keys, so you will not lose them, and you can take your money off an exchange and have them in your own management, manage your own keys, so they cannot be hacked when the exchange is compromised. So these guys have been making good money in the last months. Trezor been selling 300% more of their sticks. Well, here you see the news of the last few weeks. You see this young man in his 30s, and you see that old man in his 70s, 80s, and they have something in common. They have been scamming the world for a lot of money. Bernie Madoff did that with a Ponzi scheme a number of years ago, and he scammed the world for 65 billion, if I'm correct. Bernie was caught and got 150 years in prison. He didn't he didn't sit them out because he died a few years ago. I think he was 81. Only been in prison for a few years after a good life, but $65 billion is a lot of money. Now, this young man, Sam Bankman-Fried, now has scammed the world for about, I think it was 35 billion, which is also a lot of money. He founded his own crypto exchange, FTX, which was known around the world. A big company where lots of people invest in, a lot of people use this platform to trade in crypto. He was a philanthropist. He did a lot of business. When he saw that Luna had trouble, Luna had a stable coin, a synthetic US dollar. He invested in that to save them, so to speak. Everybody was very positive about him. As you can see, for instance, in this tweet. He had the cover of Forbes and Fortune. He went to MIT. He was an intelligent young man. Until, let's say, November 8th. Then something happened. Binance was interested in FTX. They saw they were a bit in trouble because of liquidity, and they said, okay, let's see if we can work together, maybe buy a part of the company, but we'll have to look at the books. And that's where things started going south. So management of Binance took a look at these financial administration, the figures, and they saw that something was not right. For instance, this company, this investment company, Alameda Research, which is also owned by Sam and his girlfriend, they had a very large stake, and everything which they owned was owned in FTT, the coin of FTX. So they didn't have any collateral. The collateral was the coin of the FTX itself, FTT. Now, of course, you shouldn't do that, right? So they didn't want to help them. Even more, Binance owned a few $100 million in FTT, and they decided to sell that at nearly $1 billion, I mean $900 something million. So he tweeted that he was going to sell that because something came up, right? But the manager of Binance didn't say what. That cascaded. Other people were starting to sell, and Sam said, well, don't worry, it's just a competitor who doesn't like us and doesn't want to help us. Don't worry. But that got out of hand, and people found out that there were 3 things wrong with FTX. The first thing is that it was heavily invested in all kinds of other crypto funds. And that is a big risk, right? So when this FTT would go down, all the investments in Celsius, in BlockFi, etc., would go down also, and maybe they would go broke, and that could cascade. That could be a domino effect, right? So it would be contagious to other blockchain funds, other crypto funds. So that was a big problem. The second thing that went wrong is what I already told you. They didn't have any collateral other, or hardly any other than their own coin, FTT. Now, that doesn't work that way, right? When you have collateral, it should be solid and not your own coin. And the third thing that went wrong, really wrong, was the fact that they used customer money to, for instance, help Alameda Research, right? So they used money that wasn't theirs, $3-4 billion, and invested that not in the name of the customers, in the name of themselves. Well, those are 3 things that are really not done in the crypto world, in the financial world in general. So it cascaded, and on the 8th of November, things went really bad, and Sam filed for bankruptcy. And then everybody yelled, sell, and ran away. And well, like I said, everything went south, and he is responsible for that big dip you see around 8th of November. And it was all set into motion with that looking at the books by Binance and the tweets and the bankruptcy filing of Sam. And well, a few days or a week later, and nearly all the billions were gone. And Sam said, well, I'm deeply sorry that you all lost this money and these people in his company lost their job. Well, sorry, maybe you never intended this to happen, but this doesn't cut it. I mean, we're still looking at the damage which is being done in this way, because there is contagion risk. I already mentioned that. So companies where FTX invested in now don't have any money to go on, right? And so they have to file for bankruptcy also. FTX and Alameda Research were invested in more than 100 companies and for big money. And they had big contracts, Formula One contracts. They put their name on sports stadiums, sponsorships, etc. All these contracts are gone, and all these people and companies have to look for other money. So the damage is still rolling. We're still seeing what's coming in and what's going on. Even artists who got involved with FTX, who endorsed FTX, who said, well, I'm using FTX and I'm making that and that much money. They are now being looked at, and the regulators are seeing into it if they can be charged with anything for endorsing a product like this. It's not uncommon that artists do that. Kim Kardashian also was fined for endorsing a crypto product which went south. And so I hope that these artists, these celebrities are going to take a little bit more care about how they use their fans to make money. Not only did FTX go bankrupt, on the day they filed for bankrupt, a hacker got in their system and took out nearly $4.5 million of dollars, $447 million. It was embezzled, it was taken out of the accounts, and well, these companies I talked about, Chainalysis, etc., they are still looking for it. The ledger is transparent, so you can see when people transfer money, what's going on. So everybody's looking where that money is going. But to make things worse, this happened. And it was a lot of money, because this hacker, by taking out that money, was at once, I think, the number 27 biggest whale in Ethereum. So looking at market cap, the person with the most Ethereum in his wallet. And he's been moving that money around. Like I said, these companies are on the lookout where that money comes into the real world. But he's been cutting that up in smaller parts and trying if he can throw that in a tumbler, or like Tornado Cash a while ago, and seeing if he can make this money disappear, which is very hard because people are looking, and it's a lot of money. I mean, it's not a few tenors, it's hundreds of millions. So we'll see how that is going on, and I'm sure that as soon as they have a chance to get him or her, they will. Now, this is, of course, a lot of publicity around Mr. Sam Bankman-Fried, and of course, there is a lot of interest from the public. So Amazon is looking into making a series about it. a little bit like the Wolf of Wall Street kind of movie. How has this been happening to us? First, the run up and everybody was successful, and then everything going down the drain in only a week or two. Right, so they're trying to plan out a series of 8 mini documentaries about this FTX fraud. I don't have another word for this. Okay, this is the end of the news segment and the scamming. Like I said, normally we have scams and how to detect them and how to prevent them. But this was such a big news item. We as users of crypto could not prevent that. We could not hide our private keys or whatever. This was a big company doing very bad things. Only a few people being responsible for that, like Bernie Madoff, but now Sam Bankman-Fried. I don't see any questions in the chat at the moment. So let's go on to our next topic by Jeroen Wester, and he will be talking about AI and blockchain.
Hello there, my name is Jeroen Wester, and today's talk is on AI, trust and blockchain. More completely, how could we build trustworthy AI systems by using blockchain for higher data integrity. And this presentation is all then about data and how users can trust the data that is used in AI systems. We will cover a few topics, a short introduction into artificial intelligence, and then one of the main problems that is connected to artificial intelligence and trust, and how blockchain could help there to increase the trust. And we're going to end this short presentation with a few concluding remarks. So let's first start with artificial intelligence. There are many definitions on what the field is, in this picture you see a few of the application areas that are connected to AI, like learning, reasoning, problem solving. But in general, you could say that there are 2 main approaches within the field of artificial intelligence. There's a symbolic approach where you have explicit knowledge representation, you have language models, you have problem solving and reasoning. And you have a connectionist approach where intelligence is achieved by learning from data. So fields like machine learning, neural networks, you might have heard of them, they are in this second approach. At the moment, so in this decade, the connectionist approach is the most successful approach in the field of AI. So a lot of things are happening there. But we're going to start by giving you an example of the first approach, so the symbolic approach. Here you see the Google knowledge graph in this screenshot. And the idea of a knowledge graph is that you are somewhere in a knowledge space and you have all kinds of contextual data that are related to the place where you are in this data space. In this case, there's a search term, Larry Page, and you see all kinds of connected links to this search term. So the knowledge graph is a graph of connected data, collected linked data, so that you can get from this spot, this Larry's Page spot, to things like his Wikipedia page. You can see what prizes he has won, where he studied. And this is a very helpful thing, Google thinks, because it can help you explore the space, the information space. Of course, this knowledge graph is also very important for companies because they like to optimize their presence in this knowledge graph so that they can be better found. When you're a company, that could be important. But the idea here is that knowledge is explicitly represented, and it's found, of course, but there's a there's a hard link in the data. Machine learning, on the other hand, tries to learn from data. So there's not an explicit knowledge model behind it, but it tries to learn from a training set that contains exemplary data. And by training the system, you learn the system about the data that's in the training set. And you can do something with this trained system. To give you an example, here you have a large collection of onions. Harmless example. And you could imagine that the larger picture in this on this slide is your training set. So you feed the system with all kinds of examples of onions. And you see pictures of one onion or a lot of onions in different colors with different backgrounds. But every example given enhances the understanding of the system of onions. What you need to do is that you make a connection between the picture given and the label that is connected to this picture. So, and what happens when you have trained the system, then when you present a new picture, which is not part of the training set, like the small picture on this slide, then you can ask the system with what amount of surety, how sure are you that this new picture that I'm giving you is an onion? And the system can tell you something like, okay, I think with 0.94 this is an onion, because it matches with the other onions that I've seen in my training set. And it would probably tell you also something like it's 0.15 a car, because it doesn't match really with a car. Maybe some of the curves you can also recognize in the car, but it's not a car. It's probably an onion, and it's probably not a car. There's of course an internal representation, but it goes too far for this presentation to give you an overview on how that is done. Well, this way of training a system, creating an AI, some say, can be applied in different situations. So I gave you the example of a classification system, where the trained dataset is used to guess if a new photograph, in this case, is given, then the system can classify it. It can say, okay, it's a car, it's not an onion. But these systems are also used in, for instance, in self-driving systems. Here you see an example of a self-driving car, and this car uses cameras, and it uses the cameras to get an understanding of what is around the car. And understanding the situation of the car requires that the car is capable of recognizing what is another car, and what is a cyclist, and what is a pedestrian. So this system is trained in recognizing, in the same way as with the onion example, to understand the surroundings of the car. There are many more examples of these AI systems, but I want to talk to you through one of the other examples, a text-to-image system, which gained a lot of attention lately. Stable diffusion. It's a kind of reverse classification. The onion example that I gave you is based around the idea that I present the system a new picture, and then the system, as a result of the classification process, gives you a text. So it's a kind of image to text classification. But in this stable diffusion example, it goes the other way around. It goes from text to images. So you have a trained system with pictures and all. And then based on that system, on that model, the user gives the system a prompt, a text, and then the system creates out of it a picture, and a picture that isn't part of the training set, but it is created on the input that the user gives the system. And you get these kinds of things. Here the input of the system was, okay, give me a giant onion in a field of strawberries, which is perfect and detailed. And then the system generates this picture. And indeed, we see strawberries, we see a giant onion, and we see a field. Funny things with this way of training a system is that not only the objects can be reproduced in a new picture, but also styles, colors, and spheres. That's very atmospheres. I mean, that's incorrect on this slide. So and it gives you a whole nice field to play with, and be surprised on what the AI generates for you. Okay, now you have an idea on what the field of AI is, more or less. Okay, let's now go into the topic of AI and trust. We had this example, the onion training set, where we present the system onions, images of onions, and we do so in order to enhance the concept of the AI system of onions. So in the table here you see 4 pictures. Now you see 4 links to pictures, where there is for every picture there is a label, which is important, so the system knows, okay, the picture that I'm viewing now is labeled an onion. So the model is extended with every picture in the training set that is added. And maybe the name could also be used to further enhancement of the understanding of the system of onions. But now there is a problem, and the problem is the following. The training set used, in this case for onions, could be a false training set. It could be skewed. Some onions could be more present in the training set than other onions. And if that's the case, then the AI system based on this training set will produce biased results. So if in my opinion onions are all purple, I would present the system purple onions. And so the end result, the result of the AI system using this trained set will also be purple onions. You could say, okay, well, that's not a big deal. One of the big deals is that for the user, it's very hard at the moment to understand what data was used to train the model. And this brings us to one of the ethical challenges that we have in the world of AI, in the field of AI. So the purple onions example might be harmless. Maybe biologists would say, okay, you should not train your AI systems with only purple onions because there are more varieties of onions. But it becomes more complicated when you build a training set that, for instance, connects race with criminal behavior. And you use that training set to discriminate groups of people in society. So understanding what data is used in the AI system to produce results is important for the user. Not knowing the training set and its possible skewness is a danger. And this danger could decrease the acceptance of AI systems, which is not our main problem, of course, but it could also do harm in society. So it would be better if we had AI systems that are explainable, that you can say, okay, I've come to this conclusion that I show you purple onions, because only thing I know is that the world exists of purple onions. If that's the case, then the user can say, okay, this is a very limited model that is used to train the system. So acceptance of AI systems will be higher, but the danger in society of self-explainable or explainable AI system will also be lower if people understand why the system behaves in the way that it is. Now, how could blockchain improve the trust in these AI systems? Blockchain, as you all know, probably has a few important characteristics that can be used to increase the understanding and the acceptance of these systems. One of the main things of blockchain-based systems is that the data added to the system, an append-only system, is immutable. You cannot change it afterwards. So you cannot cheat with that and say, okay, but actually green onions are also part of my dataset. Another thing that's brilliantly done is that it's publicly accessible and easily checkable. So data published in a blockchain can be there for everyone, and it can be used to check the correctness of data in an easy way. Now imagine that you build a kind of proof system or an audit trail system where you can say, okay, I can show the user what data was used in this training set and that it wasn't changed. And I can see what has been done with this data in this AI system in a publicly easily checkable way. If that is done, then the understanding of the user in this AI system will be higher, and it will be more easy to understand if the AI system behaves in an awkward or skewed way. How can this be done with blockchain? Well, easily. Imagine that you have a training set that you use for your AI system and that you create a hash out of this training set. And you store this hash in a block on the blockchain. Then that stamp proves what data is used for your training set. So somebody doing an audit could go back and could see what the hash is stored in this blockchain. And it could compare it with the training set that is told to be used for this AI system and compare them. And if these hashes are equal, then that's the truth. And the same can be done with the resulting model that is used for the AI system. Also, the hash of that model could be stored on the blockchain to see if there's no, to show what model is exactly used to produce the data, to produce the outputs of the AI system. This can all be done in a very easy way, and you see the big companies, the big IT companies, going along these lines and coming up with the first architectures to do so. But it doesn't require much. It doesn't require specific efforts to create it. You could use off-the-shelf features of blockchain-based systems in order to provide this audit trail for AI systems. So we come to the end of this presentation. I think what we tried to argue is that blockchain could be used to prove what data was used for a training set. And we can use blockchain and its immutability characteristic to prevent tampering with that. So you can prove, okay, this is the exact data that was used. And then by doing so, we provide auditors an audit trail on these training sets, on these data sets. Well, that was it. I hope you enjoyed it. Maybe see you next time.
let's see, where am I? There was a little bit of a disturbance in the force. My camera didn't react how I thought it should react, so I'm back, I believe. Our next topic will be Ethereum. Ethereum 2.0 to be precise. And you've all heard what's been going on since September 15th. Ethereum has been switched over from proof of work to proof of stake. And it's all part of the big plan, the big Ethereum 2.0 plan, which I hope to be showing you in a moment. Yeah, let's go back a little bit in time. In 2013, Vitalik Buterin, we all know him, but also a few other guys had this luminous idea of Ethereum and having these programs stored on the blockchain, which later was called smart contracts. Well, they aren't really smart. It's more like a few if-then-else statements, but still smart contracts, which was completely different than the Bitcoin blockchain, which was used up to then. Right? There were lots and lots of changes, but smart contracts were the biggest one. Of course, Bitcoin blockchain stores transactions, UTXO, and Ethereum doesn't. It stores balances. So it works in a completely different way. Vitalik Buterin started working on that. He had these ideas in 2013, and they went live in 2015. They worked nearly 2 years on it, and I think it is at the moment the blockchain not which is most used, right? Because Bitcoin is still the killer app in market cap, etc. But for business applications, Bitcoin is not really a viable product. So Ethereum and all these tokens which were built on Ethereum is the most well-known Bitcoin blockchain there is. Now let's go a little bit further in history. 2016, the DAO hack happened. Right? With these smart contracts, you could build a DAO, and well, it was all new to everybody. So they made a little mistake in the smart contract, which they wrote for the DAO, and it was hacked. Somebody took out a lot of money, and then we had a real problem. It was decided to roll back the transactions, a number of miners and users didn't concur with that. They were a completely different opinion. So Ethereum was forked. Two groups went a different way. It was a hard fork, so there was Ethereum Classic and Ethereum. Right? The same blockchain split up in two groups. Now we'll jump a little bit ahead. Because blockchain in general, for instance, Bitcoin has a special protocol, the Bitcoin improvement protocol, the Bitcoin improvement proposals. They are used to have an evolution in that technology. So people are trying to improve the algorithm, and everybody has to vote if they're going to use that, and especially the miners. Now, Ethereum has the same, the Ethereum improvement proposals, and in August 2021, the EIP 1559 got accepted and implemented, and EIP 1559 meant that the rewards for the miners, the transaction fees and the block rewards were completely rewritten, so to speak, right? In Ethereum, we had this incident with CryptoKitties where the whole network got overloaded with transaction, and so the transaction fees went up exponentially. Now that is very undesirable, because then it costs a lot of money to even do a small transaction. If you would buy a cup of coffee and want to buy with ethers, then you would have to pay $60 in transaction fee, for instance. Well, not too great of an idea. So EIP 1559 introduced a different kind of reward, a different kind of block reward. So the money that the transaction fee that was generated would go to the miner, but if it was really busy in the network, a part of that would be burned. The normal block fee would be burned if there was not enough computational power to incentivize the miners to work harder and to have more bigger pools. Now, this is a very special rule, because up to then the number of ethers was infinite. You could still generate with every block a number of ethers. And after EIP 1559, that still is the case, but it could be very well, and at this moment that is the case, that the number of ethers being burned is higher than the number of ethers being generated. Now, that means that the number of coins is not growing, but is getting smaller, right? So instead of inflation, it is deflationary, and I'll talk about that in a moment. Skipping to 2022, September 15th, that's when the Paris upgrade came. I have a list with all the upgrades there in the sideline, and you see September 15th was D-Day for Ethereum 2.0. That was the date of the merge, and the merge is a very special happening and a new era for Ethereum. Here I have a picture about the deflationary fact. Here you can see a graph of how many ethers are being generated, if it's growing or if it's shrinking. And you see in that graph that at the moment the number of ethers is shrinking. So for the same amount of money, let's say in dollars, there are less ethers. So a fiat money is considered sound money, right? It's hard as a rock. I don't think so, right? As long as Mr. Biden can print all kinds of dollar bills, there is inflation. But let's say that is solid money, sound money. Then this could be considered ultra sound money, because instead of printing dollar bills, they are being taken out of the market. Right? There are less ethers for the same amount of money, right? And in a website like that, ultrasound.money, shows that every minute what is going on. Okay, that was a sidestep. We're talking about the merge, and September 15th, these proposals for Ethereum 2.0 were shipped. It was set into motion. From that day on, proof of work was disconnected and proof of stake is the standard. Now, here you can see what the plan is with Ethereum 2.0. It consists of 3 sub-plans, so to speak, right? The first is proof of stake, and we'll talk about why in a moment. The second thing is sharding, right? Sharding is a way where you combine smaller blockchains into one large, and an improved EVM as the third thing. Now, the first thing, proof of stake, has been in effect since September 15th, and this is the way it happened. So this red tape is the old proof of work Ethereum chain. Now, what you don't want is a fork like happened with Ethereum Classic, because then all your NFTs would be on both. Your coins would be on both. So what they did was they had the proof of work, the old chain, and they started in 2020 already a beacon chain. And that beacon chain was a parallel chain. And it didn't hold the transactions, but it held the consensus part of the information. And it's been running parallel ever since. Up till September 15th, where they did the switch, where they merged these 2 chains into one. So all the information of the old chain is also incorporated in the new chain. And the consensus information, this was Ether 1 and this is, so to speak, Ether 2, but now they, to prevent confusion, they call it Ether 2.0. Those 2 layers are being combined in Ethereum 2.0 since September 15th. Now, why is that? Here you can see the triangle of the blockchain trilemma. You see in the corners, decentralization, security, and scalability. Those are 3 characteristics, and the law of physics, so to speak, tells you you can only have 2 out of 3, right? If you want scalability and security, it's probably going to be centralized. If you want security and decentralization, it probably will not be scalable, etc. Now you see here a number of names of blockchains and where they are in this spectrum. So Bitcoin is decentralized and pretty secure, never been cracked in that 12, 13 years, but it's not scalable, right? We see Ripple. Ripple is very secure and scalable, but it's not decentralized, it's centralized, right? So, and there we see IOTA, one of our favorites, right? It's decentralized and very scalable, but maybe a bit less secure. Okay, so there are lots of characteristics and they're all on this triangle. Now, Ethereum 2.0 tries to be something in the middle, and decentralized and secure, and it's going to be scalable with the use of charting. Now, proof of stake is a completely different consensus mechanism than what you know of in proof of work. In proof of work, all these miners are looking for a nonce, which generates a hash with a number of zeros, and then if one miner finds them, he gets the block reward. It's being checked by all other miners to see if he's correct, and then he gets the block reward. But they all have to invest in electricity. They all have to burn energy to prove that they did the work. That's what keeps them honest. That's the investment in the energy. Now, if you take away that investment in energy, how are you going to keep those miners honest? Not to be including fraudulent transactions in the chain. Now, that is called proof of stake. And in a nutshell, what happens is that somebody who wants to be mining a block, in proof of stake, it's not called mining. They gave it a completely different name to prevent confusion. It's somebody's going to forge like with a hammer on metal, he's going to forge a block. They have to put up money as a collateral, right? That when you look at the block, and if you do your job right, nothing is happening. If you're honest, if you're doing it all correct. But if you are doing a fraudulent transaction, then you will lose your collateral, right? So at this moment, there is a possibility to do proof of stake on Ethereum 2.0. You have to put in, if I'm correct, 32 ethers of money, of your own money, and then you might be selected as someone who can forge the next block. Right, the whole procedures here, where you can see that there is a committee of 128 randomly assigned blocks and people checking these blocks. And the more money you have, right, the more your name on the wheel of fortune will be, and the higher the chance that you will be selected to forge the next block. And then you will, if you do, then you will receive all the transaction fees, right? So with money invested, you can make money. And because you have money invested, right, that's one of the philosophies behind a proof of stake. Because of the money you have invested, the more money you have invested, the more you want this to keep its value. Now, if you would be doing your job in a fraudulent way, right, committing and approving double spending, for instance, then the reputation of the whole Ethereum chain would go down. People wouldn't want to use it anymore because there's fraud on the chain, and your tokens would become less expensive. You would lose money, right? So the more money you have invested, the bigger your responsibility for your own money will be. Okay, so that's a mechanism to keep people honest. Now here you see also that there are differences. So in proof of work, you have to do the work. The computational power is needed to find the nonce. You have to solve this cryptographical puzzle, which will cost you energy, right? And if you want to cheat the system, if you want to attack the system, you need a 51% attack, and you need 51% of the computational power of the whole world, of all miners on this planet. You need 51% of their computational power, which is a lot, but not completely undoable, right? If you would make a consortium of, let's say, 5-6 big mining pools, then you could get over that 51%. Now, if you compare that with proof of stake, well, there it doesn't depend on computational power. It depends on how much money you have, how much money you have as a collateral invested in your forging efforts, right? So you don't receive a block reward like in a proof of work, but you collect the transaction fees. And now you cannot do a 51% attack on computational power, but you would have to make a 51% attack on the money. So you don't have to own, let's say, thousands of graphic cards to have the 51% of the computational power. No, you need to have 51% of the total money invested in Ethereum. Now, believe me, if you have more than half of the world's capacity investment in Ethereum, you don't want to have it going down. So you will be sure that the reputation of the network stays intact. Then I already talked about it a little bit. The energy, proof of work, there you need electricity. Proof of stake, you don't. And that was one of the big incentives, right? By switching from proof of work to proof of stake, all the miners were switched off, and only a few miners were still doing the the testing, the calculations, etc., for approving the transactions. That in itself meant that 99.98% of the electricity which was used by the Ethereum network was crossed away, right? And here I have some comparisons of online services and how much electricity they dissipate. For instance, also some physical ones. Gold mining will cost 240 terawatt. Bitcoin is 130 terawatt hours. YouTube costs 244 terawatt hours on electricity. Now, proof of work, the old proof of work, costs 78 terawatt hours in electricity. But the new proof of stake Ethereum will only cost 0.0026 terawatt hours in electricity, which is an enormous amount less. So the world's power consumption got less, decreased by 0.2% only by switching Ethereum from proof of work to proof of stake, which is enormous, which is gigantic, right? How much energy is saved. But that's the way. I talked about these governments who are trying to outlaw proof of work. This is the reason. And we don't think about that, right? But YouTube takes a lot of energy. And there are some people who've done research after, let's say, a specific song on YouTube, how much energy that costs. And then we'll see that, for instance, Gangnam Style, right, takes away, with that 34 billion views, around the electricity of around 42,500 US homes. The average home uses a lot of energy. 43,000 of these units are used by just looking at this simple YouTube movie Gangnam Style. Gigantic. So that is a big advantage. But not only the electricity is decreased, CO2 is decreased also. And even more if you look at it relatively, right? Because CO2 is decreased by 99.992%. And if you would put that in perspective, our minds are not very good at imagining big numbers. But if you would say, okay, before the switch to Ethereum 2.0, if the height of the Eiffel Tower was the CO2, then after the switch to Ethereum 2.0, switching to proof of stake, instead of this height of the Eiffel Tower, it's only 4 centimeters high. It's so much decrease that it's only 4 centimeters versus the 330 meters height of the Eiffel Tower. Now, the electricity and the proof of stake is the first change you're going to see in Ethereum. The next change, which is on the roadmap, is sharding. And sharding is trying to prevent that it will slow down and that the size of the blockchain will get too big for a machine. And here you see how sharding works. You have some parallel blockchains working next to the main chain. So by having these separate chains, you don't have to approve all the blocks. The blocks can be smaller, the block frequency can be higher, and you will have, let's say, a little bit more central chains, right? But not too central that it's very local, right? But they will cut up into parallel chains. That's one of the ways how you can prevent the slowdown. So sharding is number 2. and then the charting is expected somewhere in 2023 to happen. There is no date yet, but everybody is waiting on that. Sharding is really hard to do. Some other chains already have some experience with that, but for Ethereum that is a very, very big thing. And the last of the three topics in Ethereum 2.0 is an improved Ethereum virtual machine. Now that is on the horizon also, but they didn't give a date. So it's not going to happen in 2023. Ethereum virtual machine is now the de facto standard of how smart contracts can be run on any chain. There are many other chains that use EVM standards and Solidity, etc. also. So they are trying to make it a bit smarter, because at the moment Solidity is a scripting language which isn't very sophisticated. Now there are many misconceptions about Ethereum 2.0. For instance, hey, if I want to run my own node, so I would have to pay 32 ethers. No, you don't. You can still be an Ethereum node. The only thing is, you can only earn money, you can only suggest a block if you have staked your 32 ethers at the moment, right? There are staking pools also with which users together have 32 ethers, but you can still, even with 0 ethers staked, you can still have your own Ethereum node. You're not going to earn money from transaction fees, but you can still be a node. People thought, misconception number 2, that the merge would reduce gas fees, would make transactions cheaper and smart contracts cheaper to run. It doesn't. That's not the real functionality of this update, right? So the merge happened with only one big thing looking into it, that proof of stake would work and that the beacon chain and the normal chain would merge into one chain, which would be handled with proof of stake. So lower gas fees might be in the future, but it's certainly not happening now. The same thing is for misconception number 3. Transactions should go faster after the merge. Nope. Not the case. Like I said, it's only for merging the beacon chain and the normal chain, and for introducing proof of stake. The merge, people think that these 32 ethers, which people have to invest to stake to be able to suggest a block and earn transaction fees, there is no way out. It's simply not implemented yet to take your 32 ethers out. And people thought that with this upgrade you would be able to. Now it's the next upgrade of the Ethereum 2.0 will be that people will be able to take their stake out. But for now, these 32 ethers are locked. And one of the last there are many more misconceptions, right? But one of the last one is that when these withdrawals will be enabled, then all the stakers will run away. That's absolutely not the case. Like I said, there are also staking pools, so you can even with a very small amount be one of the stakers and try to earn money. Of course, you will only have a small percentage of the transaction fees, but you only have to invest a very small amount of money. Of course, at the moment, in the short term, these people invested 32 ethers and it went down. As I showed you the charts at the beginning of our meetup, they've been losing money, but they also got an interest rate, which is somewhere between 6 and 14%. Now try to get that at your bank at the moment. 2 months ago, you would even have to pay interest to put your money into the bank. That is my presentation about the merge and beyond. right? So there's a nice roadmap for what I think is one of the most broadly used blockchains where you can have smart contracts. Of course, there are newer generation of blockchains, Cardano, IOTA, etc. And they all have smart contracts. They all have a way to use the EVM. But Ethereum is still the most used. Most tokens are on smart contract on Ethereum. Okay. Are there any questions? I don't see one. No. Okay, then I'm gonna go to the next point. I'm gonna be a YouTuber and say please like and subscribe to our channel because then the search algorithm will put us a little bit more up the top. I'm gonna thank you, investor, for his segment about artificial intelligence and the blockchain. And I will hope to see you on December the 22nd for our next meetup. I don't have the speakers yet, but it will undoubtedly be interesting enough. If you have interest in blockchain, you can see all the other meetups are still online with interesting topics. And I hope you will have found this interesting or valuable. And until the next time, bye-bye.